Hi, this is the next video for chapter 14 of exponentials and logs. So in this video I'm just going to show you how to solve some exponential equations that are in the form of a disguised quadratic, which you've done before, but these ones eventually will require some logs. So the first part of the method you should be very familiar with, you should already know how to approach it. We know it's a disguised quadratic because this index is twice this index, and this here is the same as 2 to the x squared. So we've got a square term, a letter term, and a number. So it's in the form of a disguised quadratic. Now the easiest way to approach it is to use a substitution, just to make it look a bit nicer. So if this is 2 to the x squared, then this is y squared minus 5y plus 6 equals 0. Now we need to factorise. So y minus 3, y minus 2, minus 3 times minus 2 is 6, minus 3 take 2 is minus 5. So y equals 3, or y equals 2. But remember, we're not solving for y, we're solving for x, so we need to put the x, 2 to the x back in. 2 to the x equals 3, or 2 to the x equals 2. Now this one, 2 to the power 1 equals 2, so x equals 1. But this one, that is not a power of 2. So at this point here, this is where it differs from what you've done previously. This is in the form base power equals answer. So we can, to get x, we can write this in log form. X equals log to base 2 of 3. Now, depending what the question asks, if the question asks for exact answers, then you're allowed to leave it like that. If the question asks for you to give your answers to a certain decimal place, then you can stick it in your calculator, and in this case, the answer is 1.58 to 3 sig figs. So depending on what the question says, if it's exact, you must give it like that. Don't turn it to a decimal. Okay, alternatively, you can work it out as a decimal. Right, next one. So this time we're going to let y equals 3 to the x. So this is 3 to the x squared. So we've got y squared plus 4y minus 12 equals 0. Factorise y plus 6, y minus 2, y equals minus 6, or y equals 2. Then we just pop our 3 to the x back in. So 3 to the x equals minus 6, or 3 to the x equals 2. And for this one, there is no value of x that's going to give a negative answer. So this one has no solution. And you must write that, otherwise you will lose a mark. So if you have an equation that doesn't have a solution, you must state that you understand that it has no solution. Don't just cross it out or ignore it. This one here, well, this isn't a power of 3, so we're going to write this in log form. X equals log to base 3 of 2. And again, either leave it like that, or if you want it as a decimal, it's 0.631 to 3 sig figs. Okay, and the last one I'm going to do is this one here, just to remind you about what to do if you don't have just a 2x and a 1x. This one you've got a 3 to the 2x plus 1. So we can't use that approach until this just says 3 to the 2x. So we're going to use this law of indices. X to the a times x to the b is x to the a plus b, because we've got an addition as an index. So 3 to the 2x plus 1 can be written as 3 to the 2x times 3 to the 1, or 3 lots of 3 to the 2x. So we've got 3 lots of 3 to the 2x. So that's this bit here. 3 lots of 3 to the 2x minus 11 lots of 3 to the x plus 10 equals 0. Now if we do our substitution, so if we let y equals 3 to the x, we've got 3y squared minus 11y plus 10 equals 0. Now we can factorise. So 3 is prime, so we need a 3y and a y. That's positive and that's negative, so they must both be negative. And then we just need to be careful that this adds up to minus 11. So for that to happen, we need to have a 2 there. That's going to give me minus 6y minus 5y. So minus 6y minus 5y is minus 11y, and those two give 10. So y is going to be 5/3, or y equals 2. Now we just need to pop 3 to the x back in. So 3 to the x equals 5/3. 3 to the x equals 2. And both of these are in base power equals answer, base power equals answer. So if we go into log form, x equals log to base 3 of 5/3, and x equals log to base 3 of 2. So again, either leave it like that or stick it in your calculator. First answer is 0.465, and then the second answer is 0.631. Okay, now based on this and the previous two videos, you should now be able to have a go at those exponential equations on exercise 14F.